Hello and welcome to Fundamental Chemistry Laboratory. We are going to be going over how to do a proper graph. Now, graphing comes up in Lab 3, where you are finding the densities of a solid and a liquid, and you have to graph your liquid unknown and then answer questions with it. Now, on page 38 of your lab book, there is some information about graphing and the rules of graphing. Now, I'm not going to go over all of these, but many of you did a graph like this, okay, where you numbered out the boxes. Some of you went all the way to the end of the axes, you were skipping lines, or you used an online program. Well, a couple of problems with that, and there's a couple of problems with the rules that I have as well. Typically, if you're given a graph, you need to encompass the entire graph space. You need to spread out your data completely. And if you look at the first couple of rules, rule number 3, it said, rule number 2 says the graph should fill the available space. So that tells me that whatever you're graphing, you should be taking up the entire space on both axes and stretch out your data. Okay, so at least in that instance, you're going to get a graph that you have to plot data on, and you've got to be able to look at a data table and determine what is the X and what is the Y, and you're going to have to scale out the entire graph. All right, you will not be allowed to use a online program. And if you do have a TI-83 or higher that has a graphing program, yeah, it might give you the slope of the line, but it's not going to plot it for you, okay? It's not going to show you what you need to count by. So in my book, this is incorrect, okay? Now, if you go through and read some of the other rules, this is where I have a problem. Rule number 2 says it should take up the available space. But then it says... sorry, I'm trying to read through it real fast. Your scaling needs to be consistent. And consistent means that if you're counting by ones, you don't go like 1, then 2, then 4, then 9. You're not plotting the individual points on the axes and then plotting them on the graph. You're counting by the same amount each time. But it doesn't say anything on here that, not to skip lines. Well, you're going to have to not skip lines, right? The range of each axis may be different, and then it's large enough to cover the needed range without lots of extra space. Your plot points do not have to start at 0, 0, is what that's talking about, okay? But there was something here... you don't need to number every box. Usually every 5 or 10 boxes will be adequate. Well, that rule contradicts rule number 2, which is you should fill the available space. Okay, so I've got a little bit of issue with the rules here. And it does say you should draw the best fit line. The best fit line is the line that goes through most of the points, but not all. It's not exactly you go to the first point and the last point and put a line between them. You want to fit the line to the majority of the data. But see, some of the data is above the line, some of the data is right on the line, and some of the data is right below. So how do we, and in the rules it talks about titling the axes with units and titling the graph. I don't think I saw any of you title the graph. So I'm going to use this as a template to write my notes on. So if you're on page 42, this was the back of your pre-lab, I would write these notes. So the first thing I do is I count up the number of boxes on X and I count up the number of boxes on Y. So we have 30 and 33. When you look at the data table, the first column is always going to be your X. It's always going to be your X. And the second column is always going to be your mass. Okay, now I know in later labs there is where you have to graph, and it's the data table is nice and long, and you've got the variable here, and then you got the numbers going horizontally instead of vertically. Typically the top is the X and the bottom is the Y if you got your data going horizontally. All right, So we know this is X, this is Y, so that's why I have volume in milliliters, mass in grams, and then the title is always Y versus X. Okay, so title is always Y versus X. So that's mass in grams versus volume in milliliters of an unknown substance. We don't know what it is. Okay, so when you go to do your graph that's in the lab, you want to make sure that you put unknown substance and then your number. You had to do the liquid, so you're graphing the unknown liquid. Okay. All right. So now that we got everything titled, the axes, the graph itself, then the next thing we have to do is find our scale. So the way you do this is you take your highest X value and you divide by the number of boxes on X. All right, so my highest X value is 10, and the number of boxes on X is 30. So when I do that math, I'm going to get my calculator up here. 10 divided by 30 is 0.33333. Okay? Now, it's pretty hard to count by 0.33 repeating. You know, you would have 0, and you always, the very bottom corner, this line is 0, 0. Okay? And you're putting the numbers on the line. Even on the side, it's on the line, not in between the space, the box. It's the line. So, with that being said, 0.33, because you have to do 3. So you could go up to 0.4, or at the very least, you could go 0.5. Okay, so I'm going to do this. I copied off a new graph, and I'll put in the labels and everything later. So here's 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 7, 7.5, 8, 8.5, 9. And then you might think, well, okay, we're at 10 already. So why do I have to keep going? And I put that accidentally on the wrong scale, because X is 30 boxes. That should have been down here. Okay. So why do I have to keep going? Because the rule is that you scale out the whole thing. Also, I wanted to show you how, well, this is actually, it's too big. Maybe you should count by 0.4s and stretch your data out more. And 0.4s would just be 4, 8. You're multiplying by 4s. Okay? So if you did round it up to 0.5, then, okay. Then, because like I said, this is the X and this is the Y. Okay? So you want to scale it all the way out. Okay? So I did do the 0.5s down here. Okay, 1, and then 1.5, 2, 2.5, 3. So it would be 10, 10.5, 11, 12, 13, 14. It would go to 15 all the way. So, and then 14, 13.5, 13, and then 12.5, 12, and then 11.5. So whatever you decide to count by, if you want to round it up to 0.5, you need to scale it all the way out. Okay? don't skip lines. Fill in all the numbers. Okay. So 7.5, 6.5, 5.5, 4.5, and 3.5. But again, I probably would have scaled this to 0.4. That way it stretches out the data even more. Okay? So you can round up to something that's easy to count, but yeah, your data is going to stop short, and then you're going to be like, well, why do I have to number out all this stuff? Okay? Now, Y has 33 boxes, so we take the highest Y value and divide it by the number of boxes on Y. So our highest Y value is 8.05 divided by 33, because there's 33 boxes. So 8.05 divided by 33, that's 0.24. Okay, so we can actually do 0.25. Okay, because that's easy to count by. So 0.25. Okay, so here the y-axis, which is math, I did it by 0.5, so I'm going to change that. So 0.25, 0.5, 0.75, 1, 1.25, 1.50, 1.75, and then 2, 2.25, 2.50, 2.75, and then 3, 3.25, 3.50, 3.75, and then 4, 4.25, 4.50, 4.75, and then 5, 5.25, 5.50, 5.75, 6, 6.25, 6.50, 7.5, 7, 7.25, 7.50, 7.75, and then 8, and then 8.25. Okay, so on the y-axis, I counted by 0.25s and got all the way up to 8.25, and that's real close to this. Okay, so really the x-axis, I probably should have just counted by 0.4s and done 0.4 all the way out, and that would have 0.4 times 30 would have got me to 12 here. So 12 is a lot closer than 15. Now, I know there's red dots here, so I'm going to use blue instead and replot this. So we had 0, 0. Then at 2 on the x, we had 1.72. So 2, 1.72 would put it up here around 7.5, so I'll say 7.2 is about right there. Okay, and then at 4 I had 3.29, so at 4 I had 3.29, so there's 2.5, let's say 2.9 is right about there. And then at 6 I had 4.86, 4.25, 50, 7.5, and 8.6 is probably right about there. 6.43 at 8, so I go over to 8, and 6.43, 25, 50, so 4.3 is there. And then at 10, I have 8.09. So 8 is right there, so barely above 8. And see how the difference is between scaling it just 10 to 10 versus scaling it out all the way, your data is stretched way out, and it's much easier to draw a best fit line, and it's much easier to find slope. Okay, so when you do a graph, your highest x value divided by the number of boxes on x, get a number. If it repeats like this one, 0.333, don't scale too high and just jump up to something that's easy to count by. Also, don't accidentally round down. 0.3 would not have gotten us out as far. 0.3 times 30 would have only gotten you to 9. Okay, so this was 0.33 repeating. You have to round it up to like 0.4 or 0.5 to make sure you go past the highest number. Here we had 0.24, so I just rounded it to 0.25 and counted out and got to 8.25. Okay, so please make sure that on your graph in the lab, you do this math, get a number, round slightly up, and scale it all the way out, then plot your data, and then do your best fit line. So I don't have a straight edge with me, so I'm gonna use this little thing. Because let me see if I can find a ruler real quick, or something that's the length of a ruler. Here, I'll just use a piece of paper and fold it in half. And then fold it in half again so it's nice and thick. Okay, so what you want to do with the best fit line is you always start with the first point and just kind of slide the ruler around until you think you've hit. You don't want to go to the first point and the last point, because that might not be hitting all your data. So you definitely, these are kind of lined up, but this point's a little higher, so you don't want to do that. So I definitely want to get these 3. And then maybe something like right about there. Okay. Because our first point did go through 0, 0, I want to try to stay with 0, 0. And yeah, that's not too bad. You got most of the points hitting right on the line. You got one above and one below. And then to find slope, you find 2 points that cross right at the x and y on the line. So this one would be my first one, and this one could be my second. You want to make both dots as far apart as possible. You could possibly even go with this one. So yeah, let's not go with this one. So this would be my x2 and my y2. This is my x1 and my y1. So to find slope, it's x2 minus x1 divided by x2 minus x1. So my y2 is 7 minus 2.50 divided by my x2, which is looks like 8.5, minus 3. All right, so 2.5 minus 7. 7 minus 2.5 should be 4.5. Sorry about the bell. And then 8.5 minus 3 is 5.5. And when I divide those two, 4.5 divided by 5.5, I get a slope of 8.8181 repeating. So slope is 0.81 repeating grams per milliliter. Okay? So you go back to your book and you go to figure 3.1 or table 3.1, and which one hits as close to 0.81? Well, not gasoline, it's too far away. 0.65 hexane, no. Methanol. Methanol hits real close, and that's why it's important to stretch out your data. Because if your data, if it was all clumped together and you got real close to 0.6, how would you choose between hexane and gasoline? 0.66, 0.655, which could also round to 0.6x. So if you crunch your data too much, you might end up with something like this, and you can't decide, and that's a 50-50 guess, and that could really hang you up. All right, so it's best to scale it out and stretch out your data so you can find 2 points that are as far away from each other to find slope. So this was methanol. Okay, and that was your answer for this. All right, so I hope this helped for Lab 3 on how to do graphing, and I will see you in the lab.